All right, basic concepts of probability, part two, part dos. Let's go. Complementary events is the big word of the day. Complementary is this, the complement of event A, denoted by A bar, A with a bar over it, consists of all the outcomes in which A does not occur. So every way that A cannot occur, the probability of those happening, that's the complement of A. Let me show you one. In the previous video, yesterday, we showed that if we randomly select an adult in the US, the probability of selecting a smoker is 0.200. Find the probability of randomly selecting an adult in the US and getting a non-smoker, which would be the complement, which is the other people not included in being a smoker. So all you have to do, total probability is 1. If you subtract the smokers from the total of 1, you get 0.800. So you have basically an 80% chance of randomly selecting a non-smoker because you had a 20% chance or 0.200% chance of selecting a smoker. That's how complements work. Just 1 minus the probability of the real thing happening. How to round these things when you are rounding off probabilities, we're going to do 2 ways really. We're either going to give the exact fraction answer. If it's a fraction, let's leave it as a fraction. Or if it's a decimal, we're going to round off to 3 significant digits. We used to call those sig digs. I think I've heard it called something different here, but significant digits. So if you get something like 2/3, leave it that way. 5/9, leave it that way. Or if you think a decimal will make you understand it better, that'd be fine, but let's go 3 decimal places or 3 sig digs. For example, let's you get this humongous probability right here. It has 10 sig digs, 10 significant digits. If you round it to 3, you get 0.902, obviously. If you get 1/3, I would leave it as a fraction, or you can round it to 3 sig digs, 0.333. Tons of people want to round 1/3 to 0.3. Don't do that. That's not what it is. It's 0.333333333. It keeps going. Don't just say 0.3. If you get 2/8, obviously you can reduce it down to 1/4, which would be great, or you can put 0.25. There's no reason to put 0.250 with the 0 at the end. So 0.25 is good enough in that case. If your third sig dig, or if your third digit is a 0, you probably don't need to put that there. All right, these are big words here. Unlikely. Something is unlikely if its probability is very, very small. We're going to use this a lot as 0.05 or less. As if it's less than that, which is basically that's 5% or less, then we're going to say it's unlikely. It's an unusually low number if the outcome is a lot less than what we expect. It has nothing to do with probability, just if our outcome is very low. Unusually high if the outcome is a lot higher than what we expect. Again, not the probability, just the outcome that we see. So wrap it up. Unlikely means it has a very, very small probability. Unusual means it's an extreme result. I'll show you a couple of examples here. Part A, when a fair coin is tossed 1,000 times, the result consists of exactly 500 heads. The probability of getting exactly 500 heads in 1,000 is really low. It's that low. If you look at that, that's less than 0.05. So when it says, is this unlikely, we would say, yes, it is unlikely. Definitely unlikely because the probability is less than 0.05. The second part of that says, is it unusually low or high? No, it's not unusually low or high because you would, when you toss a coin 1,000 times, you're kind of halfway thinking, well, you're going to get right around 500 because about half the time it's going to be heads, so that's not unusual at all. So it can be yes, no. Part B, when a fair coin is tossed 1,000 times, the result consists of 10 heads. Is this result unlikely? I mean, think about that. Even though we're not doing the math right now, the chances of just getting 10 heads, the probability of just getting 10 heads with 1,000 tosses is very low. So we're going to say yes, it's unlikely. Now, is it unusually low or unusually high? And we would say yes, it's definitely unusually low. We would never expect to just get 10 heads in 1,000 tosses. That was definitely unusually low. Hope you see the difference there. The unlikely has to do with whether the probability is high or low, or above 0.05 or below 0.05. The unusually low or high is the actual outcome itself. Okay, here's a good, this is called a probability histogram. And what this is this is tossing a coin 1,000 times. And here's the deal. Each bar, each individual bar, you can see this right here. Each individual bar tossing 1,000 times, the probability is that very small. But when you put them all together 1,000 times, this is what you get. It's a normal distribution. This red area that you see would be the part that is unusually low and unusually high. And you know what that represents too. It really represents 2 standard deviations away from the mean, probably, because the red part represents less than 0.05. And remember, 2 standard deviations away was 95. We went with 68, 95, 99.7. So these two numbers, and they're not that bad really if you look at them. So if you toss a coin 1,000 times, less than 468 is very unlikely. Higher than 532, I should say unusual, very unusual. Higher than 532 is also unusually high. So kind of weird there. Okay, a couple slides here. In a clinical experiment of the Salk vaccine for polio, this many children were given a placebo, and this many, about almost the same number, were treated with the vaccine, the Salk vaccine. There were 115 cases among those in the placebo group and only 33 in the treatment group, the same number of kids almost. If we assume the vaccine has no effect, the probability of getting such results is to be found less than 0.001. That's these results happening by chance. What does this imply about the effectiveness of the vaccine? Well, because the probability is this low of happening by chance, we would say we would reject the that's supposed to say reject the assumption that the vaccine had no effect. So we would assume that the vaccine has an effect because the probability is so low that it had no effect. If the probability had been higher than 0.05, I wouldn't have said that. But because the chances are so low of that happening just by chance, we're going to say, okay, that we're going to reject the assumption that it could just happen by chance and say that the vaccine does make a difference. I'm kind of stumbling a little bit. I'm hoping that makes a little bit of sense. I'm going to try this one more time. Because this probability is so low of that happening just by chance, we're going to reject the fact that it could happen by chance and say, okay, the vaccine was effective. I said that perfectly that time. I hope that makes some sense to you. We're going to be doing that a lot. All right, 5 quick principles, and we're done with this one. You know most of these already. The probability's got to be a fraction or decimal between 0 and 1. If it's impossible, the probability is 0. If it's certain to happen, the probability is 1. The way you write it, P of A is the probability of A. And if probability of A does not occur is the complement, and you put P of A bar, which is the complement of A, or the probability of A not occurring. Okay, that's it for today. We'll work on this tomorrow. See you there.